I want you to picture the ultimate speed limit.
You're talking about the speed of light.
Exactly. C.
It is the absolute celebrity of the physics world.
That Einstein built his entire house on. It's the ruler we use to measure everything, from the width of an atom to the very edge of the cosmos.
Yeah, it's the absolute invariant. In the standard model of physics, it simply doesn't matter how fast you are moving or where you are located. That beam of light is always traveling at that specific speed relative to you. It connects space and time into a single structure.
But, and this is exactly why we are here today. What if we've been looking at that number totally backwards? Because I've got a stack of research here. They are suggesting c isn't a speed at all.
Which is a pretty radical pivot. I mean, the source material we are diving into today, specifically looking at what is called the e-motion perspective,
Right.
it argues that treating c as a travel speed, like a car moving down a road covering distance over time, is a massive conceptual error.
Which just sounds impossible at first. I mean, we measure it. We literally time it.
We do.
But the alternative model they propose is fascinating.
Yeah.
They suggest c is actually a refresh rate.
A local heartbeat of coherence, creation, and connection.
Is the speed of light an actual universal law? Or is it just the frame rate of our local reality?
We have to look at how c was defined in the very first place, because the source points out a pretty glaring issue right at the foundation of how we talk about light.
Oh, the vacuum problem.
So if you open any standard physics textbook, c is the speed of light in a vacuum.
In a vacuum, that is the crucial qualifier.
Exactly.
Right, empty space, no air, no friction, just pure, unadulterated nothingness.
But here's the catch. A perfect vacuum is purely a theoretical construct. It literally doesn't actually exist in nature.
Wait, hold on, back up. Space is a vacuum. That's space 101. I mean, astronauts wear the suits so they don't boil or freeze in the void.
Okay, yes, space is a near vacuum.
Near vacuum.
But it is not empty. Interstellar space is threaded with plasma, background radiation, magnetic fields, charge density.
Even out in the middle of nowhere.
Everywhere. Even the empty space between atoms is just teeming with quantum fluctuations. There's stuff everywhere.
Okay, I follow that. There's dust and gas and quantum energy. But does that tiny bit of stuff really matter for the definition of the most important number in the universe?
The source argues it matters completely, because we have defined our most fundamental constant based on a condition, absolute nothingness, that is physically impossible to find.
Wow.
We have built a ruler for a universe that, strictly speaking, just doesn't exist.
That is wild. It's like measuring the top speed of a sprinter, but claiming the record only counts if they run on a surface that has zero friction.
Right.
A surface that doesn't physically exist anywhere on Earth.
That is a great way to put it.
Yeah.
The source actually calls standard C an abstraction. We use it for GPS. It works for our math. It allows us to build incredible technology, but an abstraction nonetheless.
Okay.
And this leads to the first major insight of this deep dive.
Yeah.
If the medium space isn't empty, then light isn't just traveling through nothing. It is interacting.
Interacting. And if it's interacting, then maybe what we're measuring isn't a particle zooming past us like a bullet.
Precisely. This is where we have to shift our mental model entirely.
Right.
The source suggests we stop thinking in terms of velocity, meters per second, and start thinking in terms of frequency.
So this is the refresh rate concept.
Yes.
And honestly, for anyone listening who uses a computer or watches movies, this actually makes a scary amount of sense once you hear it.
It really does. Think about a film projector, or even your computer screen right now.
Okay, I'm looking at my screen right now. I see my mouse cursor moving smoothly across the desktop. It looks like a little white arrow just gliding over the wallpaper.
It looks smooth. It looks exactly like a solid object traveling across a physical space.
Yeah.
But we know technically that isn't true at all. The cursor isn't moving in the physical sense. The pixels are just refreshing their color state in a sequence really, really fast.
Frames per second.
Exactly.
If the refresh rate is high, like 60 or 120 frames per second, the motion is smooth. Reality, or the screen's reality, looks solid.
And if you drop that refresh rate,
It gets choppy, it flickers, you start to actually see the individual frames, the whole illusion of continuity breaks.
well, the emotion perspective argues that physical reality works exactly the same way.
Oh, wow.
C isn't the speed limit of a photon, it's the refresh rate of the field we inhabit. It is the speed of coherence.
So you're saying that the reason the world looks solid, the reason my hand doesn't just phase right through this desk, is because we're both refreshing at a synchronized rate.
That is the hypothesis. The source uses the analogy of a stroboscope. Have you ever seen a strobe light hit a spinning fan?
Oh, yeah, absolutely. If you dial the strobe in just right, the fan looks like it's completely standing still. You can literally count the blades while it's spinning. It's spooky.
Exactly. That is synchrony. The frequency of the light perfectly matches the frequency of the object, but what happens if that synchrony slips?
Right.
If the strobe is just slightly off?
The fan starts to wobble. It looks warped, almost like it's bending or turning backwards.
Right. The solidity disappears.
Mm-hmm.
So in this model, C is that beat. It's the tempo at which the electromagnetic field refreshes so that we can perceive a consistent, solid world.
It's not about travel time,
No, it's about processing speed.
which fundamentally changes how we look at the universe. Because if C is a local refresh rate and not a fixed universal ruler, what happens when we look at things really far away?
Now we are getting into cosmology.
Here we go.
And this is where the theory challenges one of the absolute biggest ideas in science, the expanding universe.
When astronomers look at distant galaxies, they see what is called redshift. The light looks stretched out toward the red end of the visible spectrum.
And the standard interpretation, which we have relied upon since Hubble, is the Doppler effect.
Right, like a police siren passing by.
Exactly. It says this redshift happens because those galaxies are physically flying away from us. The universe is inflating like a balloon, so the light waves actually get stretched as they travel across the expanding space.
But the source says, not so fast.
They propose phase misalignment. They argue that redshift isn't necessarily proof of motion at all. It is proof of a difference in tempo.
The source used an analogy here that I absolutely loved. It clicked instantly for me.
The vinyl record.
Yes, the vinyl record.
It is a classic for a reason. It perfectly illustrates the relationship between time and frequency.
So, for you listening, I want you to visualize a record player. You have a vinyl record of a singer. That record represents the source galaxy.
Okay.
And it was recorded at a specific speed, let's say 45 RPM.
So the internal coherence of that galaxy, the record itself, is set to 45. Everything there is normal.
Right. Now, we are here on Earth. We are the record player. If our player is also set to 45 RPM, we are completely in sync.
The song sounds normal. The pitch is perfect.
Exactly.
That is coherence. The observer and the source are matched.
But what happens if our local time or refresh rate is different? What if we play that 45 RPM record on a player set to 33 RPM?
Well, the song drags. The voice gets deep, slow, and stretched out. The wavelengths are literally longer.
Which is redshift.
Exactly.
And if we play it at 78 RPM,
The tempo spikes. It gets high-pitched, fast and compressed. Loose shift.
here is the kicker, and this is the part that really messed with my head. The record didn't change.
Not at all.
The singer didn't run away from the microphone while recording. The record player didn't pick up legs and sprint away from the record.
Right.
The only thing that changed was the playback rate.
That is the core insight. The source galaxy might not be racing away from us at millions of miles an hour. We might just be looking at a region of the universe where the local clock, the refresh rate, is different from ours.
That redefines distance entirely, doesn't it?
It reframes distance as difference. In this model, we aren't necessarily looking across an expanding void. We are looking across a gradient of frequencies.
Mm-hmm.
And we perceive it as distance and speed because our brains and our instruments are calibrated to interpret the data that way.
It's almost like we're trying to measure the tempo of a song using a ruler.
If you measure a song with a ruler, you might conclude that a fast song is shorter or closer, while a slow song is longer or farther away.
Yeah.
But you would be missing the point of the music entirely.
But this isn't just about galaxies billions of light years away, which is what's so cool. The source actually brings this right back home.
The biological coherence section.
Yes.
We know, scientifically, that you are not a static object. You are a process.
Right. Cells die, new ones grow. I've always heard that stat that every 7 years, you're basically a whole new set of atoms.
It's actually even faster for some tissues. The lining of your gut replaces itself every few days. Your skin is constantly shedding. You are essentially a river of matter, constantly flowing. But when you look in the mirror, what do you see?
I see me. I look solid. I definitely don't look like a cloud of swapping atoms. I look like a continuous person.
That is because of the threshold of perception. The cellular refresh rate, that whole cycle of death and rebirth, is happening far below the shutter speed of your consciousness.
And the source had this really cool thought experiment. Imagine compressing a 90-year human life into 10 minutes.
Like a super fast time lapse.
Exactly.
Well, if you watched a human at that speed, they wouldn't look solid anymore. The regeneration would happen so fast that the body would appear as a standing wave.
Just matter flowing in, matter flowing out.
Yes. The source calls it a twinkling record of being. It highlights that solidity is a trick of timing. The argument is that C, this universal constant, acts as the maximum refresh rate that binds this all together.
Right.
It fixes the tempo so that the movie plays smoothly. If reality refreshed too slowly, the illusion of the self would break down. We would literally see the flicker.
Speaking of seeing the flicker, we actually have a real-world example of this happening right now, or at least a potential one.
Let's talk about Betelgeuse.
Betelgeuse, the red supergiant in Orion. It's been in the news a ton lately.
Yes, it's been acting very weird, dimming, brightening. Everyone in the astronomy community thought it was about to go supernova.
Right. But the source points to some high-res images that came out recently, and they didn't show a nice round star. They showed something lumpy.
Lumpy is the technical term, I believe.
Obvious.
No, the images showed a surface that was shimmering and uneven. Says the star is simply unstable. It's burping out gas, creating dust clouds that obscure the light. It is a completely mechanical explanation.
But the emotion perspective looks at that exact same shimmer and sees something else entirely.
Cymatics is the study of visible sound.
It's amazing to watch.
It is. If you put sand on a metal plate and vibrate it with a violin bow or a speaker, the sand actually organizes into these beautiful, perfect geometric patterns.
And if you change the pitch?
The pattern shifts. But, and this is the key, in the split second between one pitch and the next, the sand goes chaotic.
It shimmers.
Exactly. It shimmers. The geometry breaks down entirely before reforming into the new shape.
So the source thinks Betelgeuse isn't exploding, it's changing its tune.
They suggest it's undergoing a phase shift. We are seeing a mismatch between C Betelgeuse, which is the star's local refresh rate, and C local, our refresh rate right here on Earth.
The synchrony is slipping.
Exactly. The strobe light is out of sync with the fan. The star looks lumpy and chaotic, not because it's falling apart physically, but because the data stream is becoming incoherent relative to us.
That is a much less violent explanation than a massive supernova. It implies that the stability of the stars depends on our relationship to them.
It implies that observation is literally an act of synchronization.
So let's zoom out for a second. We have gone from vacuum tubes to vinyl records to lumpy stars. Why does this matter to the person listening on their commute right now?
It matters because it fundamentally changes the definition of the environment we live in. We move from a universe of dead matter separated by empty space to a universe of living rhythm.
It reminds me of that Nikola Tesla quote the source brought up.
Oh, yes. If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration.
This model basically takes that literally. It's not a metaphor.
No, not at all. It treats the universe as an actual harmonic field. And the biggest implication is definitely cosmological.
Explain that.
Well, if cosmic expansion is actually just phase variation, it solves a lot of huge headaches in modern physics.
Like dark energy.
Exactly.
Yeah.
We don't need dark energy to explain why the universe is pushing itself apart if it is not actually pushing itself apart.
It's just the music changing tempo in different sections of the orchestra.
Exactly.
Now, I have to play devil's advocate for a minute.
Please do.
Does this mean we just throw out Einstein? Do we burn the physics textbooks?
No. And the source is very, very careful about this. This isn't a rejection of the data at all. It is a reinterpretation of it.
Right.
The math of relativity still works. GPS still works. The standard predictions are absolutely accurate.
Okay, good. Because I really like my GPS.
We all do.
Yeah.
But the fundamental question is, what is the math actually describing? Are we measuring the time it takes a rock to fly through a void? Or are we measuring the synchronization limit of a field?
The numbers might be exactly identical.
Yes, but the story they tell about reality is radically different.
It's like looking at a map. The landscape hasn't changed at all, but you've rotated the map 90 degrees. Suddenly, north isn't up anymore.
And you notice things you completely missed before. You see connections that were totally invisible from the old angle.
So, if we accept this, if we accept that C is the heartbeat of local coherence, it leaves us with some really big questions.
Huge questions.
And the source actually posed two specific ones that I want to make sure we leave the listener with today.
If C is a measure of local coherence, what determines its value? Who or what sets the tempo?
That's the conductor question.
Yes. Is it random? Is it evolved? Is it an inherent property of the field itself?
And the second question.
The second is an engineering challenge, really. If our current instruments are built to measure velocity, distance over time, they will always see motion. Even if the phenomenon is actually rhythmic, a speedometer only knows how to record speed.
So how do we build a tool that sees rhythm?
That is the million-dollar question. How do we detect a shift in tempo without interpreting it as a shift in position? That is a Nobel Prize level question waiting for an answer.
It really highlights how much our tools shape our reality.
Absolutely.
If you only have a hammer, everything looks like a nail. If you only have a ruler, everything looks like a distance.
It reminds us that science isn't just about collecting data. It is about the story we tell to explain that data. And sometimes we really need to change the story to see the picture clearly.
That is all for this deep dive. Thanks for tuning in to The Rhythm.
It was a pleasure.
Stay curious about the constants.